Tilde.
What's up, North Bay Python? Hi. I'm Tilde. I use they, them pronouns. I am a senior developer advocate at DeepSet AI. And today we are going to go over that age-old question, do we rewrite our software or do we not? And some things we're going to talk about is what is Haystack, which is the open source project that I work on, and why you should care. We'll talk about the technical and interpersonal factors that go into the decision to undergo a major refactoring of your software. And we'll talk about how to be a good open source citizen when undergoing that sort of project. So raise your hand if you have ever heard of Haystack before. Now, this is kind of a trick question, not Haystack the Django package, Haystack the open source AI framework. Some of you. Well, for those who haven't, Haystack is an open source framework. It's written in Python, it's completely free, and it helps you build production-ready AI apps like chatbots, agent, document search, question answering, and that sort of thing. Some foundational concepts that will help you understand this talk that are Haystack related are pipelines and components. So pipelines are kind of like the main abstraction of Haystack. They let you define how data flows through your large language model application. Essentially, they're like a directed graph. And components are the nodes on that graph. Each one defines one logical step. One architectural pattern where Haystack really shines is RAG, or retrieval augmented generation. So large language models are great, very powerful, but much like a white man in a position of power, they sometimes confidently make things up that are completely wrong. And that's where RAG comes in, because what RAG is let's say you have a query. We can pass some data that is relevant to that query to the large language model, and so that it can then give you a probably better answer to your question. And in this diagram here, you see where it's got some documents, and that could take many forms, right? It might be like a database or a vector database, but it doesn't have to be that complicated. I will show you RAG in 3 lines of code. So here we have Haystack, which has a pipeline template for using just a plain old website as the data source for RAG. And we are saying, hey, here's a question, which is what is Haystack? Here's a URL, which is the Haystack website. Given this document, answer this question. And then when we run it, we get a response back in JSON along with some metadata. For a more production-ready example, the engineers at Airbus, I keep wanting to say Boeing, thank God it's not Boeing, they built a RAG app to let their technicians communicate with their repair manuals in natural language, when you can find out more at the QR code there. So, history, it just repeats itself. Everything old becomes new again. Haystack has actually been around since before the current large language model boom. And it focused on the kinds of natural language processing use cases that were really popular at the time, like extractive QA. So before we had generative models that are good at generating novel answers, we had extractive models that would pull an exact answer out of text, cite where that came from, and give you a confidence score, along with other use cases like summarizing and vector search. But then in 2022, everything changed when large language models went mainstream. And suddenly there was this explosion of complicated new features and use case and interest. And some of these use cases and features, Haystack was not very well architected to support based on some bad choices we made. So let's talk about those bad choices. And I have to credit the former engineering manager of Haystack for the design of these following slides. So the first anti-pattern I'm going to talk about is overexposure, where your APIs kind of show more than they should, which puts a lot of cognitive load on the person trying to use them. So you don't need to know what an embedding retriever is to look at that long list of parameters and start getting stressed out. But that's not the worst part. Some of these parameters contradict one another or overlap. So we have one, it's a Boolean for use GPU. Then you can also pass in a list of devices, which would be like the hardware this is running on. And if we know what hardware this is running on, shouldn't we be able to tell if it can use a GPU or not? Just saying. And then we also have the same kind of problem with this API-based URL, which would be like calling a large language model via API that's hosted somewhere else, like maybe OpenAI. But then also we have another parameter for the Azure version string, which should really be baked into the API-based URL if you're using Azure, in my opinion. So next we have special general mixture, which is when you try to make an API generic and you fail. So this method is a method on the pipeline class in Haystack 1 for running pipelines, but pipelines can be really different, right? Some of them might do extractive QA, some of them might be just ingesting text into a database, and so we have all these different parameters that are from kind of various domains, and they all have a default value, so it's extremely hard to reason about what might happen when you call run. We also have information leakage, which is when your abstractions kind of like let information dribble from one layer of the API to another, which a little bit defeats the purpose of having layers of abstraction in the first place. So we have this class, which is a prompt node, and it takes something which could be a string or a prompt model, so you go digging and you're like, what is this prompt model? Do I need it? And then when you've wrapped your head around that, surprise, this optional union type prompt modelification layer has entered the chat. We also have conjoined components, which is when something that really should have one job has many. Back to the embedding retriever again. It has a method called retrieve. OK, you don't need to know what an embedding retriever is to think that that sort of makes sense. It can also embed queries and embed documents. Wait, it can train the underlying model? That seems like it would have side effects and should not be anything that a retriever would have any business doing. And finally, we just kind of had an inflexible developer experience for pipelines in general. So we started out with pipelines being for question answering, and we assumed that every pipeline would start with a query like here, what does road statue look like? But then when we added summarization, it doesn't need a query, but it was a required parameter, so you had people passing in these strings that are just not being used, and it's not a good look. If you enjoyed this foray into API anti-patterns, a lot of them are from the book A Philosophy of Software Design by John Osterhout. But we would like to think that we have learned from the past with this rewrite. In Haystack 2, components have one job as well as a more consistent streamlined interface. Pipelines do not need to start with a query anymore, and they can branch and loop and have a little bit more advanced logic. We also heard from our community that people wanted help getting their apps into production, so we have more extensions for tracing, debugging, deployment, and the like. You can learn more at that QR code. But now that you know what Haystack is, let's talk about why you might want to undergo a major rewrite. But since I'm kind of feeling contrarian, let's first talk about why you might not want to majorly rewrite. Now, anytime you're undergoing a large project, it's so easy to get lost in the weeds and kind of forget what am I even trying to achieve here. So you need to really be honest and clear with yourself about what is the root problem you're trying to solve, and is a refactor really going to solve it? And programmers have been arguing about this for a long time, and they're not going to stop anytime soon. Like back in 2006, Joel Spolsky, who is one of the founders of Stack Overflow, wrote a post about how one of the dirty little secrets of programming is that reading code is a lot harder than writing it. And that's one reason why programmers just want to rewrite everything as soon as they join a new team. We can also learn from other domains that are not software engineering when thinking about this problem. I will point you towards a paper by Admiral Rickover, and I really want to call him Admiral Rickroll every time, but no, that is not his name. But back in 1953, he wrote this paper that drew a distinction between an academic nuclear reactor and a practical nuclear reactor. So academic reactors, they're simple, cheap, they can be built with off-the-shelf components, won't require any custom development, and they don't exist. Whereas practical reactors are large, heavy, behind schedule, over budget, and they exist in reality. And back, oh my God, 53 was like 70 years ago? I think this guy had a point. But to use an example that is literally a little closer to home, speaking of north and bays, how many of you lived here when the Bay Bridge was undergoing the span? Yes. Does anybody want to take a guess at how much this project went over budget? I can't hear you, but shrug. Okay, 2,500%. And it was 5 years behind schedule, and it's not really any more seismically safe than the old bridge, so the project was just a total failure. Well, what the hell happened? Well, the problem was, you see, we had a lot of architects on this design panel, not very many engineers who are actually bridge engineers, and the architects kind of overrode the wishes of the bridge engineers, and you see what happened. So rewrites are always, things are always harder than you think. But sometimes it's the right call. So how do you know when it is one of those times? Well, just go back to the identifying the root problem that you're trying to solve. My very first engineering job when I was a baby engineer in 2013 was at Pinterest. So I joined the web team and spent 2 years rewriting a Django Python app in Node.js. And then I joined the ads backend team and spent 2 years rewriting that from Python into Java. So all my experience as a production Python engineer was slowly breaking up with Python. But the reasons behind those refactors, I think, made a lot of sense. This was, this was 2013, and people knew that Python 2.x was getting end of life, didn't want to support that, and also wanted to see if we could squeeze out some additional performance. And it's easier in some ways to rewrite for performance, because if you want to keep the behavior of the underlying system the same and just swap out the underlying architecture, you can do so more incrementally. But Haystack would not have been a good candidate for incremental refactoring, because the fundamental problem that we were trying to solve was that our developer interface was a mess. And so if we just slowly added in more components, that would have been even more confusing for everybody. It just made a lot more sense to fully start over. Also, in the large language model universe, it is kind of the Wild West. People have a lot less expectations of continuity and backwards compatibility. Evergreen slide, don't at me. And at the end of the day, DeepSet, the company I work for, is a startup. Haystack is fully free, open source. It doesn't have any paid customers, because the paid product my company makes, DeepSet Cloud, is built on top of Haystack, but it's fundamentally a different product. So we weren't going to disrupt anybody paying directly by undergoing this rewrite. So then, when you have decided to rewrite, the question becomes, for an open source project, how can you do so and keep your community in mind and do what's right for them? I thought about it, and I came up with 6 kind of guiding principles of being a good open source software steward, and let's talk about each one of those in a little more detail. So it is a tenet of psychology that if you give people a voice in decisions that involve them, they will be more bought in on whatever it is you're trying to achieve. Now, I'm not saying make every decision in your open source project by consensus. No, that would be chaos. But if you listen to people and give them a chance to weigh in, they will be more bought in. And it also helps if you meet them where they're at. And what I mean by this, there were 2 sort of places that our community was already congregating online, which was GitHub and Discord. So in each community, we had one place, a pinned forum channel or GitHub discussion where hey, here is all the most up-to-date information on Haystack 2. Here's where you can post your questions, so people knew they were getting the most up-to-date information. And async text communication is a fine way to communicate, but sometimes if you need a little bit more high-dense back and forth, you might want to do synchronous calls as well. So for topics where we really wanted to dig in and understand how are people using Haystack and how can we best support them, we scheduled some community calls where people could come and weigh in. And if you're asking for a lot of someone's time, It is really best if you can aim for an equal exchange of value and make sure they're getting something out of it in return, and pay them if at all possible. You also need to be transparent, have a deprecation policy, be clear about how long you're going to support the old APIs, have release notes, put them in writing, update them regularly. All those kind of like table stakes of being a good open source project certainly apply here. When you reach a community of specific size, you'll have people in it with different learning styles, like visual, kinesthetic, audio. So you want to provide them resources to help educate them on how to use the new features. So we rolled out a YouTube channel. We had like notebooks for our interactive learners and a lot of blog posts and tutorials to get people excited. We also gamified things a little bit. So we were ready for like the beta preview stage around the holidays. So instead of Advent of Code, we did Advent of Haystack, which, thank God, was a lot easier. We just had 12 problems, and each one showed you how to use a new feature of Haystack, and we gave people like a little bit of scaffolding for the puzzle to get started, and then we would release an answer a few days later. And people gave us feedback that this was kind of like a fun, lighthearted way to learn about how to use Haystack 2.0. So history repeats itself, and all great talks end with a call to action. So now I should be telling you more about why is Haystack 2.0 great, and here's where you can find it and how to use it. But like, we're not done yet, because as I mentioned earlier, software is not written in a vacuum, and you cannot talk about whether or not to rewrite without talking about the economic forces that shape the development of software. As with many things, if you dig deep enough, the root problem with software is capitalism. And I really wish I could give you 3 bullet points on a slide about how to dismantle capitalism by Q4, but that is out of scope for this talk. What is in scope for this talk is something that I do not want to say, but I do think that you need to hear, which is that generative AI is a bubble. And by that I mean in the economic sense, where the price for a specific commodity starts exceeding its value by a lot. And we can again look to history for other examples of that. Tulip mania in the 1600s, where in Amsterdam the price of tulips spiked wildly, was the first written example of a bubble. And then in more recent history, we have the dot-com boom of the 90s to 2000, and then whatever trash fire is going on or went on with crypto. Now, what worries me, it's like if you look at this chart of stock prices before and after the dot-com bubble, and then you kind of look at where we're at now with AI, there seem to be some worrying similarities. Now, what causes bubbles? Some factors are excess cash floating around, maybe from historically low interest rates, but a lot of the factors are kind of like human psychological factors, like scarcity, be it real or perceived, and herd psychology. FOMO is a really powerful motivator of human behavior, and FOMO both causes bubbles to accelerate faster and then pop faster once they start going downhill. The first straw that broke the camel's back, as it were, with the dot-com bubble is that Japan announced they were entering a recession, and then people were like, oh, we should sell some stocks, and that disproportionately impacted tech stocks. There was a round of panic buying, and things went downhill from there. And economics are a complex system, and there's always second-order effects that you can't predict up to and including a recession. And I say this not to scare you, but just saying look at the big picture and invest wisely. And if you can afford to put away a little money for a rainy day, you'll be well-positioned or better positioned to, weather whatever happens in the broader tech industry. But also as developers, our knowledge is a portfolio too, because it takes time to learn new technologies. And do not tie your identity as a developer to any particular stack, language, framework, or trend, because if there is one constant, it is that everything changes. But unlike crypto, not sorry, crypto bros, large language models do have legitimate use cases. But not sorry, VCs, I don't think those use cases are going to include replacing millions and millions of humans just yet. Large language models are powerful, but they need supervision, and they will be at their best if they augment us. And Haystack is actually good for that, because you don't need to be an expert in natural language processing or AI to get started. It decreases the knowledge and time investment that is required to get started building cool things. So if you want to build with Haystack, learn about generative AI with absolutely no economic incentive, on September 7th, I'm running a hackathon where the whole idea is to build silly, useless, fun demos, learn, and have a good time. Come see me afterwards if you want more information. I would love to talk to you about this. But what have we learned today? So if I look at the kind of like ideological connective tissue that brings together all these guiding principles, community is an ecosystem. It's a living thing. And the sort of glue that holds it together is mutualism and reciprocity, at least if you are thinking in the long term. Rewrites, yeah. They're always more costly than you think, so just be brutally honest with yourself about the root problem you're trying to solve and whether or not a rewrite's actually going to solve it. And finally, history repeats itself. Software engineering can learn not only from the past, but from other disciplines. Lessons are everywhere you look. Thank you so much. Here's where you can find me on Mastodon, and enjoy the rest of the conference.
I'm not quite as graceful as Tilde, but had to try and